Hello, esteemed researchers community and honorable scientific committee. My name is Osman Avcı. I am the electrical and electronics engineer and master student at Menderes University. I will present you our work called Simple Design and Implementation of Two-Way Communication System through UAV. First of all, as in every study, our study emerged in a relationship between a problem and a solution. Although there is an advanced satellite communication system in some cases instead of using satellites, there are situations where it is necessary to use local base station in more rapidly developing scenarios. Such wireless communications may not occur or reach far enough due to some environmental interferences. This study has emerged as a solution approach to such situations. In the most general summary in the study, a carrier-based intermediate station was designed in accordance with the such scenarios, and the range tests were carried out. This resulted in a prototype project. The scenario followed in the study as follows. Basically, a rover and UAV were designed and intermediate base station was established between the rover and the ground control station, thanks to the router on the UAV. So the router fulfills critical task. In our scenario, the UAV carries the rover to an idle distance. It opens the mechanical locks on it and the ground vehicle is allowed to move independently from the drone and the drone rises again into the same air position. The ground vehicle is then driven to the target location and completes its last mission. Of course, within the scope of this study, the most critical issue is the relay communication. As can be seen in the animation, the communication between the rover and the control station is provided by the router system on the UAV, and the UAV can act as a base station instantly in this case. The land vehicle completes its last mission is also transported back to the mission center by the drone. Within the framework of the scenario, UAV controls are carried out externally from the system with telemetry systems. So what is the working principle? Each communication device is subject to the master-slave relationship. There is usually one common sender called master and a slave device in the charge of listening to the master. But in this scenario, we went a little outside of these patterns. In order for the scenario to be realized, the antenna on the drone needs to both receive commands from the control station and send a command to the land vehicle, which is the last point. It must work in both master and slave modes, and our work does exactly that. In this study, a SPI protocol was preferred to provide this communication and provide the conditions. We can understand the basic of the SPI protocol by looking at the graph on the left. A module that supports an SPI attacker protocol should basically have three different inputs and outputs. These are the ports called server clock, master slave, and master slave. Apart from these ports, there are slave select pin known as peripheral device selection ports. This port can be increased proportional according to the number of peripheral devices. One of the wireless long-range communication modules that support the SPI protocol is these modules called nRF224L0. They basically operate in 2.4 GHz band and support up to the 125 data channels with 1 MHz gap between them. After selection a communication module and protocol to be used, a UAV, rover, control system, and router system were designed implementation in this scenario. Firstly, a simple design drone was created that performs the most basic task. Our pilot software was using a software as in the UAV, which is that is of communication module, control receivers, motors, battery, propulsion system, and autopilot board. In the diagram on the left, you can simply see the basic avionic connection, and on the right, you can see the implemented drone. Likewise, a rover is needed and prototype rover has also been designed. On the screen, you can see the electrical connection schematic of the rover that has been designed. One Raspberry Pi modules, nRF24 wireless communication modules, Arduino, and motor driver board are used to be drive the motor. Here, there is the visuals from the construction and integration stage of the rover design. A wireless remote control is needed in order to steer the rover. In this direction, a wireless remote control system was designed and the same communications module was also used in this control system. You can see the connection diagram on the construction phase images on the screen. Finally, there is a need for a router system, which is the most critical device to be placed on the UAV. A router was designed using the same modules and integrated on the UAV. As for the algorithms and software used, this issue was discussed under three headings: the software of the ground station called transmitter, the software of the router, and the rover called the receiver. If we look at the transmitter software first, as it can be seen, the addressing of the modules has been done in the illustration part. This is very important and the matching of the modules is also critical for them to work in master and slave relationship. And again, thanks to the stop listening parameter and the last parameters in the setup section, these modules work in master mode and directs the data from the control router. The second software that we will consider is the software of the router modules, and it is a different algorithm structure from the other software. As you can see, two addresses are made in the module called router. One of these addresses for receiving the incoming data, and the other is transmitting the incoming data to the same address receiver module. These two addresses function in different parts of the algorithm as slave and master modes. In the first half of the algorithm, the module working in slave mode receives the incoming data, and the second part it switches to the master mode and sends the incoming data to the receiver. Another thing to note at this point is that the read and write channels are created at the correct addresses. We see the parameters correct in the two last lines of the setup part of the card. And finally, the algorithm on the module is called the receiver, namely the rover. This algorithm is the same as the logic of the control software, only because the module will be slave in the section. It addresses as 0002 to match with the router and works in receiver mode with the last two parameters in the setup section. As a result of all this information and studies, field range tests were carried out on two different scenarios. These are divided into the urban and rural areas. In the urban area test, if communication was made to antennas, it would have maximum range of 330 meters. But as a result of this study, it reached 650 meters, which is almost twice the range. The same tests were carried out to rural areas concept at the same efficiency was achieved, and the range reached up to 3 kilometers. As a result of these tests, it was found there were delays between the command and the rover vehicle between 200 and 250 milliseconds. To sum up, the study is in the form of concept project that has achieved and its purpose and is open to development. Thanks you for interest and time.